Unit 7, Bonds, Introduction to the Measurement of Interest Rate Risk, Lecture 9, Convexity. Now up to this point we've only used duration to estimate the change in a bond's price when yields change. Now, modified duration is the duration measure we've used, but this calculation is only accurate for small changes in market yields because we use a linear approximation. The yield curve is convex, and the way we approximate the change using duration is we draw a tangent to that line and we work out the slope of that tangent. But as you move away from that tangent point, your estimate is actually going to become less and less accurate. And that's why we bring in the concept of convexity. And the slide, or the next slide, is going to give you a much clearer picture of what I mean. And as I mentioned previously, looking at the slide gives a much clearer indication of why duration is not sufficient when you're trying to estimate price changes, because you notice that as you move away from the tangent, then it over or underestimates the price increase or decrease as a result of the change in yields. Now we're looking at convexity, which is actually very important for two major reasons. When you look at the yield curve is convex and slopes down, and as you go down the yield curve, it actually flattens out. So what that means is that bond prices are more sensitive to interest rate changes at low yields than they are at high yields. And that means that duration actually changes as you move from high yields to low yields. Also, as a measure, duration is a linear approximation, so it's only really good for small changes in yield. The second reason for convexity being important is that bond prices respond differently to increases in yield than to an equal decrease in yield. So because of the convex nature of the yield curve and the flattening out at the bottom, bond prices increase more when yields change than they decrease when yields rise by the same amount. So the convexity is actually desirable, and investors prefer more convexity to less, and convexity is largest for bonds with low coupons, long maturities, and low yields. So here we have the formula for convexity, and it reminds us of the formula for effective duration. Below that we have the convexity adjustment, and please remember that the convexity adjustment is always positive. And here we have the formula which will help us to estimate a bond's price change given both the duration and the convexity adjustment. Example, you own a 6-year bond with an 8% coupon and a 1,000 Rand par value, which is currently priced at par, meaning that its yield to maturity is 8%. Based on a 50 basis point change in yield, what is the effective duration and convexity? 50 basis point is a 0.5% change in interest. So in this slide, we're going to use our financial calculator to calculate the information we need. So the price of the bond when yields increase by 0.5% to 8.5 is 977.23. The price when yields decrease by 0.5% to 7.5 is 1023.47. The par value is 1,000, and the change that we're looking for is 0.5%. So we calculate our effective duration to be 4.624 years and our convexity as 14. Using this information, we will now calculate the estimated percentage change in price. So for a 100 basis point increase in yields, which is a 1% increase in yields, the change in price will be minus 4.484%. So prices will decrease by nearly 4.5% when bond yields increase by 1%, using the information on duration and convexity we calculated in the previous slide.